Steve's Physics channel. I'm Steve, and today we're going to be looking at the last problem in this series of a block sitting on a slope. And in this case, we're going to change up the numbers a little bit, but we have an 8 kilogram blue block and a 6 kilogram orange block are connected by a wire over a massless frictionless pulley on a 45-degree wedge with a friction coefficient of 0.35, and I show it in the picture up here. And we want to find the acceleration of the blue box during this situation. So go ahead, pause the video, try it by yourself, and when you're ready, I'll show you how I did it. Welcome back. Hopefully that wasn't too bad. First thing I like to do when I solve this is I wanted to write out all of the given variables. So in this case, we know the mass of both of the blocks, we know the acceleration due to gravity, and we know the angle of the wedge, as well as the coefficient of friction between the block and the wedge. What we want to find is the acceleration. So the next thing I did was I wanted to write down the force diagram for each of the two blocks. So in this case, I started with the orange block. So the forces are pretty similar to the last few. We have gravity going down, and we have the normal force that's perpendicular to the wedge, and then we have tension pulling up towards the top, and we have friction opposing the tension. Now we have 3 out of the 4 forces that are all at an angle to the normal XY axes, so I'm going to rotate those so that those 3 are lining up with the axes, and we only have the force of gravity at an angle. Next, I looked at the blue block, and this one's pretty simple. We only have 2 forces. We have force of gravity going down, and we have the tension going up. Now for both of these, the blue block and the orange block, I wrote a little red arrow in there. That red arrow is just to represent the direction that I assume is going to be the positive direction and the direction that those blocks are moving in. Next, I'm going to write out Newton's second law equations for each of the forces and blocks. And I started with the orange block in the x direction. If we call upwards as positive, then we'll have a positive force of tension subtracting the component of the force of gravity as well as the force of friction. And we're going to set that equal to mass of the orange block times acceleration. Next, in the y direction, we're going to have the normal force going up, we're going to have the component of gravity going down, and it's not accelerating in the y direction, so we're going to set it equal to 0. And next, we're going to be looking at the blue block. In the y direction, we have the force of gravity going down, which we're calling the positive direction, and then minus the force of tension going up, and those are the only forces, and we'll set them equal to mass of the blue block times acceleration. Now to solve for the acceleration, I'm going to solve for the force of tension for those equations that have it in there, and then I'm going to set them equal to each other. And when I do that, I find that we have mass of the orange block times acceleration plus mass of the orange block times gravity times the sine of the angle plus the force of friction is equal to mass of the blue block times gravity minus mass times acceleration. And that is one long equation that's a mouthful, and it's only going to get worse because we do have to make a substitution for the force of friction. And when we make that substitution to solve for the acceleration, we find one big long equation. And thankfully we know all of the values for all of the variables in it, and all we have to do is just plug it into our calculator. And then when we do all of that, assuming we did it correctly, we find that the acceleration is equal to 1.59 meters per second squared. Hopefully that wasn't too bad for you. If you do have questions, please leave them down in the comments below, and I'll do my best to answer them for you. If you liked this video and it helped, please leave a thumbs up and subscribe to my channel for more content just like it. And until next time, have a great day.